Humanoid robotics just entered a whole new gear, and it all started with Tesla. After Tesla revealed that Optimus is already on a live production line with a much larger Gen 3 line coming next year, the rest of the industry snapped awake and fired back with major announcements of their own. First, Figure AI dropped a bombshell. Their robot has been quietly helping BMW build over 30,000 cars in the last 11 months. 10-hour shifts, Monday to Friday, 90,000 parts loaded. Second, Sunday Robotics unveiled a breakthrough in robot training, teaching tasks using simple glove-based demonstrations. Training costs down from $20,000 to just $200. That's not just an improvement, that's a revolution. Third, China's UBTech shocked the entire robotics world by claiming they've begun mass delivery of several hundred humanoid robots on $112 million worth of orders. Is this real progress or is it a publicity stunt? We'll dig into that. And finally, we'll look at Xpeng's new humanoid robot, which many are calling the closest thing yet to Tesla's Optimus. The bot races on and is accelerating fast. Today, we have robotics expert Scott Walter, a two-time robotics company founder, joining me. He'll explain what this all means for the future of humanoid bots. Welcome, Scott.
Hello, Herbert. It's nice to be back the evening before Thanksgiving. So we'll make sure to have an extra helping for everyone who's going to be watching this tomorrow.
Well, we loved listening to you and you teaching us what's going on. So what I wanted to do was take the roundup of all the major bot announcements in just the last couple of weeks here. And there's some big ones. So the first one, of course, we saw this. Tesla rolled out and showed a video of a production line, a pilot production line already running in Fremont, and significantly larger Gen 3 production line coming in 2026. Says we're already testing our factories in office spaces for real-time use cases, and the goal is 20,000 cost of goods per robot at scale. Haven't asked you yet, but what did you take about this particular video here?
Okay, well, this is actually a video that was shot in the spring, just before I think it was the quarterly report they shut out, where we already had a glimpse of what the pilot line looked like. We know that for a couple of reasons. One, because the tendons on the hands are still white. They're not color-coded like they shifted to. And the other is like right up there on that screen. And that one right there, if you close on up there, you're going to see it says April 8th, 2025. So that's sort of what the state of it was. So we don't know what the state of the line is right now and what they're producing on it, whether they're still producing the Gen 2.5, perhaps just for internal training purposes, because they can't be doing Gen 3 because we don't think the Gen 3 design is locked down yet, unless they're maybe starting to produce certain components. But I don't see why you would be running a line except for maybe testing the actual production, the production methodologies you want to employ.
Okay. And so this is the Gen 2 and
what they call 2.5.
2.5, yeah. So they've stayed pretty quiet. Tesla, they don't want to reveal Optimus 3. They said that will come maybe March or something like that. And do you think that's the right strategy for Tesla, to just stay a little bit quiet, don't show anything?
Yeah. Keep them guessing so you don't know. So basically the golden robot that we're seeing is the robot that's being produced there. They just changed the color scheme a little bit. They basically just kind of spray painted the cover a little bit. And that's the one that you got to see live. So congratulations on being invited to the shareholder meeting. And you had enough pull that you're able to sit in the front row and ask Elon a question, but not enough pull to get me a ticket. So
next time you'll be the bot that will come with me.
Okay, so what was it like seeing it live?
I wasn't that impressed. Like you said, it's 2.5. Did moves. We'd already seen it dance. I didn't expect it to do anything more that would have impressed me. I purposely was saying to folks, I do not want Tesla to show the Gen 3. I don't want them to. And I'm glad that they didn't.
Now, you did get to see the hand. So
Yeah. You got comments about that? You saw it up close?
Well, no, I didn't see it up here. You saw it up close. And the closest I came to seeing it was at the 1010 event. And that was like the early prototype. And it was like really distant. And then some people get some better images of it. But I think Alexandra and others uploaded some, and also Gail, some images. And I did a pretty lengthy breakdown of that. And the fact that the hand now has color-coded tendons, because the problem was in the pilot line, they were mixing up the tendons. They didn't know which one was which. So now if you look at it, they're color-coded. And when you look at that color coding, you can sort of figure out which is which. So there's black, blue, red and green tendons. and we can follow them all down, and we know how the stack is. So originally I said there was like probably 24 actuators. That's wrong. There's 17 actuators in there now, because there's a stack of 12 down here and a stack of 5 up here. So it's not like the 3 that we thought. And that the extensors, the things that make your fingers return, they aren't using tendons. They're using, I guess technically you would call them like ligaments, basically very stretchy tendons, otherwise known as like a rubber band, or, not exactly a rubber band, obviously something of higher quality that causes them to spring back. And then you can see a red tendon going right on through and going right on down, and then you can trace it right onto it, because they reveal the whole forearm in those images, which is nice. And you can also see then there's like a green tendon for bringing the pinky and the thumb over. So there's like 2 there. And then you have the black and the blues, which do the abduction and the adduction. So we can get an idea of how it's working, what the 22 DOFs are. And I think based on some of Elon's comments, they may be increasing the number, because he said they're going to 50, because the numbers he gave didn't quite match what's there, because he said something about 26 in the whole arm. And if you do like the 17 plus the 2 for the wrist, it's 19. It's just like too much. But then it seems like they're increasing the count, and they're increasing the count by about 5. And that means they're getting rid of the extensors, which are rubber bands right now, and they're going to make them active. So more than likely, they're adding more to get full actuation, because right now it's a little bit under actuated when you do that. And that's probably what they're discovering is a little bit of problems. They're also doing some tricks that we'll see if they turn out and where they change it. So what they've done in the abductions, in the way they get the fingers and everything kind of going on through here, is the offsets are set up such that they potted the fingers, the tendons up high above where that joint is. And they have it up so high, it's actually in this phalanx right here, which means when they pull on that for abduction, they can actually cause it to flex a little bit, which is interesting. So by doing both together, you get pure flexion. If you just do one, you get a little bit of flexion, and you also get a little bit of abduction. That's the problem, is that you induce the two. Yeah. By putting in the extensor, they'll be able to control that a bit better. But the idea of having both those down there is what it means is they can get a much stronger grip. You get 2 tendons pulling down on there, which means you can close that a lot harder, and you get much better grip strength. It also looks like they intentionally, those tendons that are used for the flexion, only used for the flexion of these 2 IP joints up here, and not the MCJ or MCP joint down here. So it's a devious little strategy they're using to kind of control that. And I think they realize, we can't do it with rubber bands to pull it back. And that way they can get a bit more control, a bit extra grip strength. And what it means is that they don't have this clawing motion when they close. That right now it kind of closes down like this because it can't control all the IP joints. But by separating it out, they can actually have it straight and then control that a bit more. So that means they have finer control overall. And I'm assuming that's a strategy they're moving ahead with, probably the Gen 3 hand.
Wow, Scott, it's amazing what you've figured out here. You're the expert. Do you think this is going to pay off for Tesla? They seem to really focus on the hands. I've not seen anybody else do it at this level, but is it going to pay off for them to spend that extra amount of time and effort and money?
Well, they have to. But the thing is, there's this trade-off. I mean, there's always trade-off in everything, cost, dexterity, robustness, and everything else. And if you want to do everything with it, it might be really hard to come up with a hand in your first generation that has the robustness you want. And so we're seeing a lot of high dexterity hands out there. You've seen like the Sharpa hand was out there, the Wuji hand that recently came out, and they're all putting the actuators in the hand. In a couple of cases, they're actually putting them right at the IP joint. So basically you have a motor right there that forms the hinge, and you're able to control it that way. And then Wuji said, wait a minute, we're going to actually make the phalanx out of a motor, have a little transmission that goes ahead and does, and that way you can put a bigger actuator in there and controlling it that way. And they get extreme dexterity and full control, and it's absolutely amazing what they can do. The problem is they all overheat after about 30 minutes because there's just so much, the actuators and everything are just getting too hot. And so in many cases, the strategy of going with the tendons, the idea is that the heating problem will be down here. We can control it better rather than having hot hands, which you don't want to have. And when they overheat, you can't use. So robustness is a problem everyone's having. And this is what I'm saying is you can either have a dexterous hand or you can have a robust hand, but it's going to be really hard to get both. And Tesla has to make that decision, is that what do they want to get out of the Gen 3? And I would assume you want robustness. You want the bot to be able to run and run and run. So I'd be willing to sacrifice a little bit of dexterity here and there just to be able to do something. But
for the first
I'm not the engineering guys who see these new wonderful materials coming out of SpaceX and controls and stuff like that. So, I'm not going to second guess what they're doing, but it's a challenge. There's no doubt about it. And it's not just a challenge for them. It's like for everyone. We have yet to see a dexterous, robust hand. And when I say robustness, it's one thing to say you can show your hand and bang it with a hammer and you'd say, see how tough it is? It's like, it looks like it's robust, but the reality is it actually running on the floor for 11 months in doing real production?
Okay. Well, that's Tesla. And that's a good segue because Figures came out and they said, well, hey, our bot is actually already running on the floor doing real production. They said that their Figure 2 robot, again, they've already shared what Figure 3 looks like. Figure 2 contributed to the production of 30,000 cars at BMW. They're going to share their learnings from 11 months of deployment. To that, they said these bots ran 10-hour shifts, Monday to Friday, 90,000 parts loaded, 1,050 hours of runtime to production of 30,000 of the BMW X3 vehicles. And they estimated 1.2 million robot steps that these bots took. This is the video that they shared. I'm going to take off the music here. Were you impressed by this drop? Did it scare everybody? Look how, robustness there, right?
And if you've seen some of the Boston Dynamics videos, they also kind of scratched up too. So, it shows it was really used in production. It got banged around and, was able to keep going on. So of the 30,000, there was 90,000 parts. So that means it was contributing about 3 components per car, if I do my math right. And as far as those the BMWs, I saw one of them. It came off the line. It was actually parked in front of Figure HQ. So, Brett picked up one of them. And again, if you look at the hands, you can see how they've been a bit dinged up, but they're still working. And to me, it looks like he's probably a left-hander because that's where most of the wear and tear is, or at least the operations required the use of the left hand a little bit more, whatever they were doing. But that's the kind of rigidity or ruggedness and robustness you're going to need to operate nonstop. Now, this isn't 24/7. You got to start somewhere. It's still impressive to be able to do one shift Monday through Friday. And of course, gives you enough time to evaluate how the bot is performing to make sure it's ready to go the next time. So no one wants these things to be in a super mission critical situation yet, but we're getting closer. And I think that's a bonus because we've heard of some other test cases where they didn't go so well with the bots that they gave up after a month because they didn't see a return on investment. And we're going to talk about that at the very end.
Okay, so you're feeling like this was a success and that there's an actual humanoid robot that's actually doing useful work today. This is an image of the bot in front of the workstation. First use was sheet metal loading, classic pick and place in automotive manufacturing.
Yes.
The associate picks sheet metal parts from racks, places them on a welding fixture, of which 6 industrial robots weld and feed the parts into the main line. So they
that's feeding. Like I call that, feeding the robots. The cook is at the robot zoo.
You call it cook.
And we talked about that. This is the low-hanging fruit that I expected Tesla to already be doing. And Elon even mentioned that would be one of the applications. And right now there are 30,000 cars running around out there that were built with the help of a humanoid. And they were not from Tesla, which is kind of surprising because I've felt they have so many opportunities on the SNX line in Fremont. Again, one of these lines is only Monday through Friday, one shift, that you could go in there and you can do a lot of experimentation. And
maybe
there's not just a couple of cells. There's a lot. There's so much opportunity for it to go in there. And again, I haven't considered buying an S or an X, but if one of them came out and said body by Optimus, I might, And so, please do that. And then, go ahead and put it on there and let us know that the content was produced by Optimus.
Yeah, for sure. So I'm pretty confident that they're already doing it. So this is, and wrapping up Figure, they actually did tell you what they're trying to 3 critical KPIs, right? Key performance indicators. Cycle time. The requirement was 84 seconds total. 37 seconds load time. I'm assuming, Scott, that is probably like faster than human or same as human. If they can't do that?
No, it may be slower than the human or about the same. That's how much time the human has to do it. Now that's a pretty long cycle time by the normal automotive standards. Usually they're down around 49 seconds, but this is a special kind of vehicle that's not high volume. So that means there's a lot of excess time in there, and they were able to make that window quite comfortably. So
placement accuracy, it's got to be at 99% success per shift. Interventions, number of times a human must pause or reset the goal. The goal is 0 per shift. The challenge of this use case is balancing speed and precision. placing parts with a 5 millimeter tolerance in just 2 seconds. So they did not share what their actual, that was their goals. They didn't share how often. But, if it was 11 months, then maybe they hit it, that the BMW is willing to keep going at this, or at least showing improvement, right?
Yeah, it's a success no matter what, because of the amount of data you get from that experience. You know what worked, what didn't work. They'll be able to find out, is it ready for deployment? And the thing to remember is that Figure 2 was never meant for scaling. And the idea was to start getting into some of these pilots, and now Figure 3 is coming in. And so we don't know at this point whether there's a new contract where Figure 3 is going to be going in there to test it out in the same kind of environment. But yeah, we'll find out.
Scott, what's the trade-off between right now, the Optimus 2 and the Figure 2? They look strong. They're made of steel, and then, but obviously we've seen Figure 3. It's much more of that cloth covered feel to it. And I'm sure Optimus 3 will be something very similar. But then when they're in a factory, they're going to get banged up, ripped up easily, right?
Yeah. But you can change the outer coverings. So we've already seen that Figure 3, you can put different kinds of coats and jackets on it that might protect it. The other thing is that soft covering that's on there is easily removable. That pops off and you can replace it with something else. So it doesn't have to be that. You could just say, we don't want it, or we're going to put something else that's way more durable for it. So it doesn't have to be cloth, which you might say, it's not quite right in that environment because it's going to snag or this and that. It's something that's designed to be a little bit softer when you're around people. Probably the only thing will depend upon heat transfer, what they have, whether they want to have a good airflow or something like that. But I'm sure there's other materials you could use that would be designed better for an environment like. The other thing is maybe not having a hard metal exterior would be better. Then it wouldn't get scratched. It's because you'll have the soft outer coating that cover that will sort of take whatever that hit was that caused that little mar, that little scratch on there.
Should be like humans, right?
Yeah.
Just enough that you don't cut. But
you wrap your Tesla right for a reason, because of the road. You don't want all the stuff coming up from the road. You just don't want to scratch your paint job.
So we've got Figure and we've got Tesla. Clearly, the leaders in U.S. We're going to talk about UBTech. They announced that they have hundreds of humanoid robots, Chinese, and then Xpeng, another Chinese. Do you think that these two are the leaders? We've seen 1X drop theirs as well, but more for the home. Is there anybody else in the U.S. or European market that you think is the real leaders?
They're all leaders in certain respects. How you rank an overall leader is really difficult to say. Is it ability? Is it success rate? The kind of industry you're going in. So the UBTech deployment was not a surprise, because they were kind of telegraphing that since the summer, that these orders that were coming up, what they were doing, showing they're going, and they're going for that real low hanging fruit. Going into the warehouses, figuring out what the bot spec needs to be for that. And I said this before: is their bot is very mid. So it's just average from top to bottom. But in some cases, that's all you need to have an MVP that can go out there and do it. So they can't do backflips like the Unitree, but the Unitree doesn't have hands and it's too short, stuff like that. So Unitree will be number one in that kind of category. And UBTech, 2 meters per second is all they can do when they walk. Actually, that's pretty good, because you only need to 1.2. So it's got the right speed. It has hands, which are just 11
we'll cover
dots.
UBTech.
Yeah, it's enough to.
Yeah, sure. Yeah, so it depends on, we'll get there, because they're going volume, and they're trying to say that they're leader in terms of mass delivery.
So if you get it to be, have just the right functionality and no more, it's not that difficult to imagine you'd be able to scale, especially over where they are, in that there's so many suppliers. It's not like it's a problem getting the actuators that you would need and all the other components. So it's not that surprising that they would. And again, we're not talking about tens of thousands. We're talking about hundreds, which is already a big thing. But I don't think they're planning to ship 1,000 by the end of this year. It's going to be the high hundreds. But next year they may be talking thousands, and 10,000 bots per year is 40 a day with only a 5-day work week. So when you break it down, those numbers, you realize it's not that big a number to be able to hit it. So I think it looks impressive when you see a couple of hundred of bots fill up a room.
Okay. And then I was going to ask you, so as of today, right, you've got bots. They showed prototypes, and then they're showing that you can train them. with AI, and then you're showing that you can manufacture them. And when we spoke to a bunch of CEOs, they would say, at first it was, manufacturing is ahead and AI's got a lag. And then all of a sudden it flipped, and all of a sudden became AI training was a lot easier, but manufacturing became the hard thing to get durable actuators. Where are you today? Most bots companies, which one is the challenge, the biggest concern for them right now?
All of them are still challenges. So a lot of the designs are beginning to realize when they get the prototypes in there, they're not as robust as they hoped. So actuators will overheat or they'll break, and they're not sure if it's the design or if it's the supply chain. So that's kind of slowing it down. That it would keep companies from like scaling up to tens of thousands already because the supply chain's not ready for it, the design's not ready for it. And at the same time, they're trying to catch up with the AI. So it is that weird race to sort of see where you are. Some people think, the hardware is way ahead of the AI right now. And this is where you have to be careful to make sure you don't design hardware that's so good. It's just not, the AI is not there. And then you have capabilities you can't tap into. So you need to kind of balance the two. And that's why I don't mind seeing people going out there coming up with designs that might be very average overall. It doesn't have full dexterity, full degrees of freedom, but you can start getting them out there and getting some real data and maybe start training and staying more narrow. I'm not a big fan of trying to race for AGI right away. It's like, go for ANI, artificial narrow intelligence. Look in the factory floor, really try to nail certain kinds of applications from it and find out what the challenges are. And from there, you may figure out how to then go to AGI. But, AGI is the type of thing, until you have it, it's just really hard to deploy it. It's this weird chicken and the egg. You can't get in there. So I think you've got to start with something that is manageable. Average hardware, average nets, get out there, get the data, find out what you need to do, repeat.
Okay. And then before we leave Tesla, did you have some news to share about where you think the actuators are made? One of the things I think you might have fed this to me was, why did Elon say at first, he said, we're going to have 10,000 Tesla Optimus bots by the end of 2025. And then he quickly backed that down to, hundreds. And right now it's already the end of 2025. We don't even know at this point how many they've made. But part of the reason I think it is because they realized that the actuators was going to be a lot harder to buy off the shelf. And instead they're going to make it themselves. And which makes sense. If this is the critical component, Tesla will not want to outsource it to vendors. They'll want to have it themselves or, do both. And then, so what did you find out about Tesla's actuator strategy?
Okay, so my understanding is that they will probably want to start manufacturing in-house eventually. Clearly, they've been testing different supply chains over there to get the prototypes that they need. And they found out there was all sorts of issues with the actuators, overheating for whatever reasons. And I think they also found that it was very difficult to ramp up to the volumes that you want because it takes so long to make some of these components. So there was a bit of a rethink that's like, okay, let's slow it down and start over again. So they were getting ready to ramp, but again, many of these components take, the order of tens of minutes to like an hour to produce, which means you might have enough comkomponents for one actuator from one machine per day. So
and you need 44 or something like that.
Yeah, you need a lot. You need a lot of very specialized equipment to be able to make these things. And a lot of that's because the nature of the way prototyping is done is very different when you go to scale. So when they start going to scale, they can start knocking these components out a lot quicker. But then your capital expenditure is really high, and you better make sure you have your design right. Otherwise, you're spending a lot of capex unnecessarily. So I think it was Tesla Yoda is speculating based on a job listing for an Optimus actuator engineer, I think quality control engineer that is based somewhere in your neck of the woods, which is.
Well, I'm in Seattle, but I grew up in Vancouver, Canada. So
yeah. So it appears to be just outside of Vancouver that there's some speculation that, and it's something to do with, I think, a Sumitomo plant that's up there, and Sumitomo makes certain kind of actuators, and they were like a world leader in a certain type of a cycloidal actuators. I think they're like these RV type of actuators, which is a rotary vector actuator, which is a kind of a hybrid between a planetary and a cycloidal.
Linear.
And it's possible they may be doing that. I mean, that's very, very speculative at this point. I have no indication that that's the way. It wouldn't surprise me if they decided to do that, which means they've given up on harmonics and are kind of going in a different route. And the RVs are kind of a happy blend between the good properties of a planetary and the cycloidal by getting rid of what are kind of the downsides of it.
Wonderful. Yeah, we did a show one time. You explained all the different kinds of actuators, and Tesla seems to, combining how it functions, right? Linear, planetary, linear, or rotary, and then now you're saying it's like some even new thing.
Yeah, and of course we don't know if again that's going to be producing the volume, because they're going to need a large volume for this, and Tesla has announced various production plans and facilities and where they're going to go, and. Do you think it's kind of early for them to be either? I don't know if they've been. No, that was officially. Elon talked about 10 million Optimus at Austin and like 1 million in Fremont, without giving a time frame. And I believe Joe Tegmeyer has videos sort of showing what he believes is clearing the area for it. And so, do you think it's premature to be clearing land?
Not at all.
Yeah. Why? Why do you think it's not premature?
What it takes years. So you have to build the factory.
You remember how long it took to get Berlin to get up and running?
So within 2 years, it should be up and running, and by then you want the line. I mean,
yeah. And I think it's a little bit more than that. We're spoiled by how fast Giga Shanghai came up, and we just assumed, that's gonna be everywhere. And Berlin and Austin were like painfully slow. And part of it wasn't just clearing the forest and like that and erecting the building. It was like stuffing the building full of stuff. Some of the equipment you can just get. Some of the stuff is like back order of years. So like, GigaPress, you just can't get one like that. Now, Optimus, it should be a little bit different. You're going to not need GigaPress and some of these other things, but you're going to need the supply chain. So, I kind of trivialize and says, 10,000 Optimi, that's 40 a day. Yeah, assembling
each of those bots require thousands of parts. And each of those parts need to be its own production line.
40 times 30, that's like now suddenly 1,200 a day of just the actuators you need. So someone's going to be producing 1,200 a day. Now, whether that's going to be happening,
per 40 bots. Yeah,
exactly. So you get 30 times 40, and if I do that right, that's 1,200 actuators per day just for that 10,000.
I thought it was 44 actuators per bot. Well, how did you get
something like that? It's like the math is easier this way. So I think it's
gotcha.
Well, okay. I'm thinking of the structural. So just the big structural actuators is about 30. I think Elon was saying it's going to be like 100 for the whole bot, because now he's counting the hands. So these are these other. That's a whole new thing right there. So almost half of them are in the wrist and forearm, and the other half is there. So if you want, you can say somewhere we've got a supply chain that's going to produce 100 of these things. That's going to be like 4,000 a day that's coming out of somewhere. And is that going to be some facility that's up in Langley, Vancouver, or British Columbia, or something else? You're going to have to scale up to that. And that's what we're just talking about, 10,000 a year. All right. And you want to say, we got to multiply that by, we got to multiply it by 100 now all of a sudden to get to that million just for Fremont. And then if you can get Fremont flowing, now I want to up that another 10. It takes a while to build these things out. So they don't know what they're building yet. 100%. They know it's going to change, but they have a rough idea. They know enough that we can start getting these lines out there. We can start doing it. We can start ordering stuff, because they're going to be having to order a lot of equipment. You just don't order one gear machine and say, turn the dial and please produce 10,000 an hour from me right now. No, you need a lot of grinding machines.
Okay. Thank you for that. That's Tesla. That's Figure. Let's get to the training again. So there's this new company called Sunday Robotics, great name. They came out of nowhere, felt like, and they seem to have caused a stir because of their new way of training robots. So Tony Zhao, he said, today we present a step change in robotic AI, introducing Act 1, a frontier robot foundation model trained on zero robot data, ultra long horizon tasks, zero shot generalization, advanced dexterity, and the bot looks like this. So they decided, I think, you tell me if I'm wrong, they said, what we're really building is not the form factor. What matters more is, can you train it quickly And can it in zero shot, meaning like once you train it once, it can actually do it right away.
Yes.
Tell me what we're watching here. What's the big advance?
Okay. So they're not so much out of nowhere because we know Tony and we also know his other co-founder, Cheng Chi, fairly well because they've already done some groundbreaking work. Tony, when he was at Stanford with the Aloha project.
Oh my gosh.
Then
That's
also,
them?
yes.
This is the Aloha project?
Well, and Cheng with what's known as UMI. So they were like two different ways of working it. So Tony was doing it. He was showing that with teleoperation and with very simple kind of end of arm tooling, you could in a very short period of time be able to get reasonable success rates from the robots. And you remember when that came out that both you and I were shocked. It's like, what?
Yes.
You know, with less than 100 samples?
No, it's 500 tries of a teleoperation, it can get to 85% success rate. Like let's say pushing a chair into the under the table or pressing an elevator button and I was like, for such a cheap project, $25,000
but it got better. Over time, they were able to do a lot of things where you had like less than 100 in there. And I think you were getting maybe 70%. And then, to get higher and higher, you need a little bit more. That was pretty good. And they were doing remarkable things with very simple paddle grippers that I thought you couldn't do.
Right.
like use a zipper or tie a knot. And now what Cheng was doing is that this idea of the universal, I think it's a universal manipulation interface, where rather than having a teleoperator train something, come up with a glove that you can actually stick on someone's hand. So the person is actually grabbing it and you're grabbing the data around their hand on their glove. So rather than them being remote, they're actually there. And so the training mechanism that they have is identical to what's on the robot. So that means you really are showing the robot what its hands are supposed to do, what it's supposed to see, what it's supposed to feel, everything. All of that is there. And then they don't care at all about the embodiment. So the whole idea is that later on, we're going to figure out how to stick it onto an arm. And so it doesn't have to be this arm. But they also realize that, Aloha, if you think about it, was more of a software play and that they were using off-the-shelf hardware. And the assumption is that, well, they could just use off-the-shelf hardware as well. And they was like, you want to intertwine the two a little bit. So they found they could get much better results by controlling their own destiny, by becoming more vertically integrated and coming up with their own hardware rather than relying on a third party. They could move a lot faster that way. And so there's no teleoperation that's been done in the training at all. It's just basically hands floating in space, if you want to think about it, with someone with a mounted camera on their head. So that's all the robot has to do is sort of duplicate the head position and the hand positions, and then they figure out with the kinematics how to do it. Very clever solution for mobility that will cover like 80% of the use cases in the home. You're going to hear complaints, but it doesn't do stairs. And my response to it is like, if you're complaining about it can't go up the stairs, then you must be really impressed because, that means it's doing everything you want it to do. You just wish it would do the floor up above. So that's a minor complaint. The first thing is being able to do tasks like this. And it's rather remarkable that it's not only doing these tasks, but these are long horizon. And that's been the problem for a lot of systems, is that when the task gets too long, it gets kind of confused and doesn't know what to do anymore. So long horizon planning and the training. So their real paradigm shift here, and it always has been, is this idea that the data is important and how you capture the data is better. And they don't think doing it with teleoperation is really the right way, but using these Yumi kind of hands or gloves is actually the best way. So once again, they kind of caught the attention of everyone in industry to think kind of, okay, is this the right paradigm, or do we need to start thinking about the problem differently? But yeah, you can see the robot, even with that base, works very well. And
he was saying this situation here, they're calling, what do they call it? Like, it was making a mistake. It was trying to do something with the garbage can, and then it just kept trying, and it will just keep trying until it gets it right.
It's trying to find the tabs. So I assume you also have KP duty, especially after Thanksgiving dinner.
Yes, I do.
And that when you reach down there to get the tabs, do you always get it the first time?
The tabs of the garbage bags?
No, the tabs for the dishwasher. The soap tabs.
Okay, that's what it is.
So it's doing everything. So not only is it wiping the dishes off, it's getting the soap tab before it finishes the whole job. And so it was like missed a couple of times until it finally got it. And
Gotcha.
I usually fail the first or second time too. They just slip out of my fingers.
So can you just explain what's going on here? So obviously I can see zero shot generalization. Yep. What does that mean?
That means once they have trained it, it just goes. They don't have to go and do any post-processing on it. So once they run through the simulation with zero shot, it just works the first time without any touch-up.
I get the idea of this glove. Okay,
I take this a little bit further, what they mean by the zero shot. One of the things they did is they trained it sort of in their own home environments. They got a lot of training data. The question is like, all right, what happens when we take it to a completely new set of surroundings?
You have to train it all over again, I guess. But okay, let me understand
They took it to an Airbnb, 6 different Airbnbs, and they ran the same thing, and it ran their zero shot. They didn't have to retrain it for that.
So I guess let me understand what's going on. So you're using a glove to teach it how to take dishes from a table and put it away in the dishwasher. Yes. But how does it know? So like you grab the glass and then you walk over to the dishwasher and then you put it in this way.
Yep.
And then once that's done, it's now got its own eyes and it'll somehow know that you're supposed to grab a glass and then put it away this way. And if you grab a utensils, you put it in this way. What?
So they're training a series of tasks, and the operator has also a forehead mounted camera, and the robot has a forehead mounted camera. So that hat you see underneath the hat, even though the eyes aren't actually cameras, there is a camera up there. So that's the data they have. And from that data, they are able to train it through imitation learning on what it's supposed to do. And once they have enough of that, the robot can now generalize just enough that you can tell it, all right, clear the dishes off the table. And it knows what
dishes are. It knows what utensils are. It knows what glasses.
And it knows
how to grab it.
Exactly. So it's not like it's a table setting of 3 all the time. It could be different table settings, things slightly different. So it generalizes enough and knows how to put those in. And it generalizes enough that you can now go to different home environments. And zero shot, it will go ahead and figure out. So you can see that's a very different one than the first one we saw.
You're right. And somehow it knows what a dishwasher is and knows how to open that dishwasher if it's trained on
different dishwasher. Now, I'm not sure if I actually had a chance to talk with Cheng yesterday, and they are having to train different dishwashers. Of course, they don't have the full set, but eventually they'll be there because each dishwasher is a little bit different. Because you'll notice that it even did the start sequence. Not only did it close it, it pushed the button before closing it. So, but the buttons are always on different sides. So it's going to have to learn to generalize on things like that. But it has the general idea of what a kitchen is. It recognizes a kitchen. So you bring it into a foreign environment and it'll go, oh, hey, there's the kitchen. That's where the dishes go. And then it will go in there and it'll say, oh, that's where the dishwasher is, and knows how to open it up. So that's one of the ideas, is that once it learns these things, you do not have to retrain it or touch it up in your environment. This is the other thing that's very impressive, which Cheng said he had tried to do this teleoperation. So they took like the Aloha project and they tried to do the same thing with folding socks. And he said it was difficult, if not impossible. I don't think he said he was ever able to get it because he wasn't getting that sense of force feedback. And with socks, the force that you apply is sometimes you have to apply a lot of force to get it to stretch just right. And then also you have to have, just the right touch. And so you're looking at those hands, you think, oh, those are ski mittens. There's like no way it could do something like folding those socks in there. But it has just enough dexterity because it knows enough from the human operator of how you do it with hands like that. So they believe in minimal degrees of freedom, just as few as possible. Let's see if we can get ahead and do these tasks that appear to need a more complicated hand. And they're like, no, you don't need 3 degrees of freedom, or just right. We have the paddle that's kind of there to give you more surface area for being able to, if you want to pick something up, you can have those fingers that are there for support. But if you really just need the 2 for dexterity, that's enough. So it's a very interesting approach. And what do you think of the bot itself for the home environment?
Looks cute. Looks good. Yeah. I don't like that. It's a base of, giant wheels underneath. I don't know how successful that would be. But
it won't be successful in all, but there are many home plans where it will work. So, that's the thing I've said about wheeled bases, is that, there's a lot of areas in the home that can't necessarily go in and it won't work at all.
Like in my home,
may be a certain percentage.
Yeah. I've got an open layout, which is good for it. But in order to get into the living room, there's 2 steps.
Okay. That can be a problem if you get little steps. Door jam shouldn't be a problem. Thin carpeting should not be a problem because it's got at least 1 inch clearance. So that means you can go to the beta program and go in there and you'll be
I'd love
screened
to
out.
do the beta program.
You'll be screened out because it's like, oh, you got a stair. It has to go up the stair.
No. There's a lot of space. There's a lot of space.
I'm hoping they screen you out. Okay.
No, I want to be part of this, dude. I want to be part of the beta program. But so first of all,
okay. So your impression, you probably showed your family this, and was their impression not in my house, or was it like,
oh, no? I've not shown it to anybody in my family, but I would put this in my house. No worries.
Okay. But I have,
I love it.
and
It's cute.
I've shown the other bots to my family, and they're all like, not so sure. Because I think there was one comment that was really funny from someone that said something, finally a humanoid bot that doesn't look like it'll kill me in my sleep.
Yeah. It's cute.
And that's the first thing is everyone, and the other is that everyone's afraid the bipedal bots are going to fall on them.
Exactly.
And this one here just looks safe and friendly.
I agree. I love it.
And the first impression of my family was, oh, you can bring that one home. The others, not so much.
Agreed. So look, let's just back up a bit. You got Tesla, clearly a leader, unbelievable. They're going for it. They've created this incredible hand that can do all sorts of things. They created their own actuators. They're gonna do this massive factory. They're gonna go for it. You got to figure already has their bots. They don't have as good of a hand, but they are showing it to be at work already, and they're building their factory. Then you have companies like this, and we'll talk about the Chinese ones. And these guys are going $200 to train, and we'll get there. That was the next big aha moment for them, is because their model, instead of teleoperation, you're using the gloves. That's captured gloves, 2 orders of magnitude higher capital efficiency, because in order to train it, just $200, not 20,000. And you can see that the bot, like you said, they went with 2 degrees of freedom, which is pretty cool. You got the finger here, but then you got the hand here, but you don't have all your 5 fingers. Elon was saying that it's surprising you do need that the pinky. Pinky comes for all sorts. It probably won't be able to sew, but they showed that they can fold socks. So they're going with low cost, easy to train, and but still apparently based on this, we can train to do all sorts of tasks. Who's doing it right, or maybe there's a role for everybody.
There is a role, and nobody knows yet who's going to be right. So it's a different paradigm, and experimentation like this has to happen. So it's good to see someone is taking a different approach, and also someone is trying to get into the homes very quickly by having a bot that looks like it'll already be reasonably safe to be around, and not trying to do too much. So we focus a lot about being able to thread a needle. And I just asked Herbert, when was the last time you had to thread a needle? When was the last time someone in your home actually had to sew?
No, I actually did one recently. So yes, I did.
Okay.
Like 6 months ago.
I can't remember the last time anyone in our home. I don't even know where the needle and thread is around. So maybe
I got to do it. Yeah.
Yeah, and I think there's a lot of people in that situation, and that it's kind of rare. However, how often do you have to put the dishes away? How often do you have to fold laundry and stuff like that?
True.
So what you should be doing is focusing on the 80%. And if we're waiting for the bot that will be able to thread a needle, we're going to be waiting a long time. And so if we say, oh, okay, I'll do the sewing on my own, but all these other tasks, please take care of it. That will happen a lot sooner. So right now, everyone's kind of doing it with what's the capabilities are today. And in 5 years, we'll look back at these things and we go, oh, we can't believe we did that. Was so crude. But to get there, we're going to have to take these very simple steps.
Okay, so this is Tony Zhao. First of all, I'm still shocked because you and I did a show maybe 2 years ago, 3 years ago, whatever, and it was on this Aloha project, 3 PhD students from Stanford showing that they can do it. So now he has a real company and it's really successful. I want to meet Tony because we were so impressed with them way back then. I love it. I'm glad that they did this.
Don't worry, Herbert. I'll introduce you.
Thank you. Please. We should bring him on the show.
Actually, there's a story. There's a story there. It turns out that one of the videos I did, not with you, but like a super nerdy deep dive that I did with Mara about the singularity, was actually shown to the design team because Cheng was having a hard time explaining to them what a singularity is and the difficulty of it. And then I ended up getting a shout out from Shi Yang, who is a designer, who said it really helped in that particular episode. And because of that, right after the release, they reached out to us and said, yes, you can interview us. So it turns out you
got to get me a part of that.
All the stuff we do sometimes comes around. So
we do know that people watch our shows. I know that the Tesla executive team, lots of analysts, executives, and so they watch it for experts like you. And you've already shared so much information just now. Thank you for that. I want to meet Tony, and I want to get their bot in my home. It took us over a year to engineer the core infrastructure. We then spent the past 3 months, that's it, to produce all of the autonomous results above. So, he's going for speed of training. He's going for just the right balance, like you said. So it's interesting. We'll see if it's true, but this is an example of what they will accomplish. Sunday Robotics, they came out of nowhere, it seemed like.
They did an outstanding job of being in stealth because a lot of the people around there were not aware of it.
He goes to wine
a lot of
glass
people
loading.
who were in the know were not aware.
Is the most delicate subtask. Yeah. If you much force, you shatter the wine. If you insert the wrong prong, you shatter the wine bag glass. So they broke many, but now 0 over 20 plus live demo sessions. Yeah. That's incredible. One less known fact about the glove-based data collection: it produces higher quality data than teleop on contact-rich tasks. Remote teleop can't provide good force. You talked about this earlier. Okay.
That's the problem. Yeah, is the force feedback. You absolutely need it for a task like that.
They're calling it Memo, and we deployed in 6 unseen Airbnbs, and it was able to do it. We train on data from over 500 homes. The new home is instantly familiar to Memo. Bring it to my home, Tony. Bring it to my home, please. I'm a fair product manager. I'm a fair. Okay. UBTech on a scary side. That was a cute side. That was a good design. I guess we have to talk about Cobot because that thing can still hurt people, but it can run me over, run a vulnerable human, my child, or things like that. But UBTech is scary. These guys is a Chinese-based company, and they've announced they already have $112 million worth of orders, and they're beginning mass delivery. A first batch of several hundred Walker S2s for key industrial uses in automotive, smart factories, intelligent logistics, and data collection centers. So they are showing photos, and some people think that this is faked. Others, no, they've made this many already. This is crazy. What do you know about these guys?
Okay, well, they've been around for a while. UBTech is a well-known brand over there. This is the Walker S2. I remember already looking at the Walker S1 maybe a little over a year ago, and I wasn't that impressed with it at the time, but this is like an improvement over it to the level that it's kind of just at the point that it's scalable. And I did a post about 2 months ago about it to say that it's so mid, it's perfect because it's average in every category that you need, and that it was both scalable and deployable in certain situations already. So this did not surprise me, plus the fact they had already announced back in August that they're going to be doing something like this. Now, this is a nicely produced video that they put together. This is kind of proof of how they shot it. But this is not the actual one that they released because they kind of took the iRobot vibe of how the robots were delivered in the movie iRobot, which had a very kind of gray palette and a kind of dystopian vibe. And so when they finally shot this thing, or like, the final version of it, you almost thought it was CGI. I mean, there's a lot of people who first really thought it was CGI. And even people who are used to seeing CGI were, and being able to tell the difference, had a hard time knowing it was real or not. And I think part of it is because they intentionally made it look like CGI. And I've seen a lot of things. So the final version, you'll see the drone shot, like some of these things here, the shadows are kind of weird. Everything about them, they almost look, if not CGI, almost like claymation kind of stop action movement. And in this drone shot, there is a door way in the back, a big blue door that you can see in the far corner that's in the raw footage. And the final footage is not there. It's like they airbrushed it out. So there's like all these things they did to sort of change the tone. So you see the blue door way in the back right there? That's the raw footage. When you actually watch the actual release of this, you will see the palette changes a little bit, and you'll see some things are washed out. And I think they almost intentionally wanted people to think it was computer graphics, just because you end up getting the engagement you want from social media. And that's clearly what they wanted, is they wanted people to be tricked, to think it was that. And the one thing you might notice in a lot of the images, did you see the number in the upper corner? So I just want you to go back to a couple of the first slides that you did. and you'll see that there's a number, and the number is 9880.HK. Do you know what that is?
Hong Kong price?
Yes, that's their listing on the Hong Kong exchange.
Oh, okay.
Yes, so they're a publicly traded company, and of course, their stock value, I think, almost tripled very soon after this announcement.
So do you believe them that they've received $112 million worth of orders that they've created?
Yeah,
These are all real?
I believe they have, and I believe that they started the delivery, and I believe that they have produced that number, and that there are probably customers who are taking it. The other thing is that some of them might be going to actually training centers. So a lot of them might be, it's like another division that we're shipping them off to. That's a different profit center that's going there. It could also be going to real customers. But what we really need to be checking here is that not so much whether this is the world's first mass deployment, but whether 6 or 9 months from now, we have the world's first mass redeployment where a lot of them come back. That's the big thing. So again, I say you can make the bots cheap, you can make them scalable and get them out there, and you can get them to do certain tasks. The question is, what's it going to be like 6 or 9 months from now? Whether the customer is going to be seeing the ROI, where ROI is king. And again, that's my French joke because it's pronounced "wah" in French, which means king. So king is king, ROI. And without that, that is the only KPI that matters. I mean, we can go through all the other stuff. In the end, all those KPIs are what determine return on investment or not return on investment. So let's wait and see.
Wow. Like you said earlier, each bot seems to have one thing that they're doing that's a good value prop, different than others, maybe leading in that area versus the others. This is great. That's one Chinese company. Another one is Xpeng. And people are saying that this one is very, is this the one that they call their bot Iron?
Yes.
And they say, some people say it's the most close to a Tesla, but I don't see that as close to a Tesla. Okay, so there's two versions, right?
Yeah, there's two versions, and they've been working on this, I think, 2019. So Xpeng is very similar to
the
Tesla
first one?
in that they have an EV division,
Xpeng,
and then they started the humanoid division in 2019. And similar to Optimus in the sense that it uses a lot of linear actuators, but it's very different than the Optimus design. It's not like Kepler. Kepler is a complete ripoff. This is like their own unique design. And it's a very attractive bot. There's no doubt about it. So he always walks very gracefully, looks very human-like, but has been deployed in the factory. But it turns out that after about a month in the factory, their hands were breaking down just from using a screw gun, maybe just the vibrations from it. And this is coming from Xpeng themselves. The CEO actually said that. So right now, they're not thinking of put it in the factory because they're not getting that return on investment, and they're looking to put it in somewhere else and start doing the R&D. But in the meantime, they've come up with a second version of this bot. So this bot is already very human-like, very nice, and I'd say very similar to almost in the sense of its grace. And then this one comes out, which I call Iron Maiden. So there's two things that are going on here with Iron, is that they have now gendered bots. So they have two versions of the bot, a male and a female. I believe the male is actually a little bit taller than the female. And you can see the walk here. Now, the original Iron already had a very convincing kind of walk. I mean, he would command the presence in the room just the way he walked. The thing is, he walked gracefully. He didn't walk fast. And we can see Iron Maiden is doing the catwalk. And the catwalk is a difficult walk just because the balance has to be just right. But there's also something else about a catwalk. Besides being very convincing and being very human-like and making you almost think it's a person in the suit, a catwalk is intentionally slow. So it tells you nothing about the actual capabilities, walking capabilities. It's just that it can be very convincing to the point. And this is another thing, because this is the controversy before the last controversy. So UBTech was all about, was it real or not? The week before, Xpeng also was whether it's real or not, but one was it CGI or not? In this case, was it a person actually in the suit? And do you know where that rumor began? Who planted the seed of that rumor?
Tesla had something like that, right?
No. Tesla had nothing to do with it. The actual rumor began with the CEO in his keynote address, where he suggested, people are saying it almost looked like a person in a suit. And a lot of people were like, it's a person in a suit. And then
no, but I mean,
the next day they had to cut it open to prove that it wasn't. They won the engagement war. I mean, it was great. And they even have it on display now in a mall in there, the controversial bot that everyone thought was actually a person in a suit. And the kinematics are interesting. I mean, when we do the breakdown, they added a lot of degrees of freedom that no one else has, which is why it's very human-like. Do you want to hear what they are?
A little bit. Yeah, I do.
Okay.
I mean, it's like, so, what are they shooting for? Like,
okay. Normally in the arms are attached to the torso and that's it. So we have a 7 Duff arm up here. They added the scapula. So 2 more degrees of freedom. And the scapula is what gives you hugs and shrugs. Okay. So it can come out in front. So that means the shoulder is able to move back and forth. So now their arms are really 9 degrees of freedom. The waist, usually everyone is like, agility has 0 degrees of freedom in their waist. Tesla and Figure have basically 2 degrees of freedom there. UBTech or Unitree and others have like a 3 degree freedom waist. And so usually it's between there. They'll have 0, 1 or 2 or 3. And there are some that just have 1, they just rotate around. These guys decided 5. You know, what? It's like, let's skip right over 4 and go right to 5. So they've added a lot of redundancy. So it's not so much a waist as it is almost a spine that gives them a lot of that movement. And I'm not sure how necessary it is. I mean, I suppose maybe for some human movements, it's going to be interesting. They also made some adjustments to the way they're doing the actuation in the hip that I think are kind of clever refinements and improvements that I'm really glad there was a controversy about whether a person in a suit, because they actually have a special covering around there to make it very soft and the other fabric that goes around. But I couldn't see the mechanics that was in there. And because of the controversy, they had to say, no, it's real. See, this is what the robot really looks like. And then I was able to get in there and take a look.
It's amazing what you pick up, man. You pick up everything, every single pixel on a show. Yeah, you understand what's actually going on, what they're lying and what they're not lying. It's cool. Everybody's got their own angle. They're all trying to get that publicity. Some people are actually selling it, supposedly. $112 million worth of orders. They're getting out there saying, hey, we're first to sell this many. Others, like Sunday, our bot works and it's going to be low cost, easy to train. It's going to have its place. Wow. The robot wars are happening, eh?
Yeah. I mean, and what's been lost is if you look at, I don't know, the past 6 or 8 weeks, it's like every week there's been a big announcement. So, I mean, it's like, it seems like last year, but you know, was this fall, 1X announced going into the home, and they kind of like definitely won the social media engagement. They even made it all the way to Comedy Central about that coming on in there. And then I think maybe it was like right after that, the H2 bot, which is pretty much the adult size bot from Unitree, comes out, and then you get the Xpeng. and then you have UBTech coming on after that, and it's kind of, and then Sunday comes out, and Sunday came out on a Wednesday, and unfortunately, like 3 or 4 other robot companies came out on that day, and they get completely overshadowed and forget. You know, so there is Tangible is one that's looking at. I think Agile in Germany came out. There's a couple others. I mean, it's just there's so many. There's just been swamped in there, and everyone's going to be very careful. It's like, is this the week we should announce or not? Is someone else going to come in here and steal our thunder? So there's a lot going on, and it's very hard to keep up with everything right now because of all these announcements.
Can you give us a little bit of your time frame? Because I know that here's my understanding of what happened. 2 years ago, January, so maybe a couple more months now, it's 2 years ago, you and I started doing videos. And the general sentiment at that time when we did ours was people said, you guys are crazy. This is not going to happen in my lifetime. It's going to be decades away. Nothing's going to happen. January, February, March, April, all of a sudden we had one after another of bot announcements. And then over the course of a year, demo. Chinese, everybody dropping demo. But they're just demos of prototypes. But now the sentiment has flipped to the other side. Oh my God, these bots are going to be in my home 6 months from now. It's going to be millions of them next year. And but then, you know, we needed to tell people, well, actually, the actuators are not that robust yet. They're still working on the hardware. There's a lot of time it takes them to create these things. They can demo you, and you can watch a video, and it looks great. It doesn't mean that these things are in any way ready to sell. So where are you at with this, and what is your recommendation to people who are watching this in terms of their expectations for humanoid robots in terms of time frame, next year, 2 years, 3 years from now?
Okay, so definitely long-term bullish, short-term a little bit bearish. You have to be patient. You have to understand
Yeah.
it's an ascent business right now, and it's going to be a long time before anyone is really profitable and the sales get up there, because there's still a lot of engineering that has to be done. A lot of things have to be figured out. There is definitely a certain amount of excitement, so you need to just kind of keep your expectations under control and realize it's long-term. It will happen, and you already can get some bots in your home. I mean, there are people who have bought the Unitree bot and then brought it home. It's like, probably not recommended to do that around small children. Know exactly what you're doing.
Mm-hmm.
And it's not like
Mm-hmm.
it's going to be a butler doing anything. It's going to be something that you can test and have a little bit of fun with. So in some ways you can say they're already there, but the ones that we're looking for that you really say, oh, I can bring in the house, or I can make it as like a gift for my elderly parents to help them with the chores and like that. That's 2030 earliest. Okay. So
the home,
let's say 2030s,
right?
2030s is the home. There will be some early deployments in the home for people who are lucky with 1X and stuff like that, who are able to do it. But the idea that, oh, I can just go out and like buy them for Christmas for some friends or something like that, you're looking at the 2030s. Maybe I'm wrong, because I know there's some people that are more bullish that are like, oh, by 28 or 29, you're in that. It's like, well, there's a lot that has to be done. First, the AI has to really be general purpose. And second, it has to be very robust, but the cost has to be down so people can actually afford it. It looks like the costs are getting down there in many ways. And maybe it's because the components are a little bit too cheap. They need to be a little bit more, but the costs seemed like they're also already under 30,000 or something like that, maybe even more. So it's getting in the affordability, but it doesn't matter about any of those things. There's only one thing that matters.
Cobot.
Safety.
It
has to be safe. And we just don't know when the bots are going to be safe enough or certified safe enough, or the capabilities. And there's so many different ways you have to approach it. Is that ideally everyone would like it that it is just inherently safe, that, the hardware and everything is set up. There's no way it's going to, so you do a lot of things to soften and stuff like that. The reality is these bots are going to fall over. It's just going to happen. And you can't have a massless bot. They're all going to have some sort of mass. So you're going to need active measures. It just cannot passively take care of everything. There's going to have to be some active measures for the bot to gracefully power down or to gracefully fall, to do things to avoid some sort of injury. And, that's going to require safety standards and people understanding that. So it's going to be a combination of two. You try to do as much by the bot just inherently when it falls over that it's not going to hurt, but it's just not going to happen unless it's a beach ball. And bots are not going to be beach balls. They're going to be made out of stuff that, people, when we fall, if we faint, we can break something, not just ourselves, if we fall the wrong way and hurt someone. So hopefully when the bots have a fainting spell, they know what to do. For the first few seconds, they figure out what to do and then get themselves down on the floor.
I agree with you. So thank you for doing that, because that's what I've been trying to tell people too, is that so many people have now switched to the point that, oh my God, I'm going to have a bot in my house in the next year.
Yeah.
Yeah. Safety is the thing. But in the warehouse, here's figures saying we already have been helping BMW. And at some point, if it hadn't already happened now, maybe next year too, it will be, as you called it, useful work. You have a variety of criteria to determine if something's useful work, such that a company truly, not just because they want to beta test something, they really want to buy it now because it replaces humans, that actually save them money over the long term. It truly does the job as fast, or like you say, maybe doesn't have to be as fast because they've got 3 shifts, but like the business model works that they want to do it now. They'll go, please bring them in now.
Exactly.
When does that happen for the factory?
To me, it seems like it could almost be happening now in some of those low-hanging fruit.
Simple pick and place, right?
Simple pick and place. They may not quite be there yet, but they should be getting close. I'm not sure why we hadn't seen it from Optimus already. And
they don't want to share it with you, but they probably
part of it.
are.
But the other thing is the type of hands that you go with. My feeling is that the current Optimus hands, the 11DOF hands, should have been sufficient enough to be able to do a lot of sheet metal thing. There maybe it was like always a hard time to get it out of the bin, but once it's in Optimus's hands, it seems like it can get over there. And it looks like it may have had enough durability, because we can see figure was pretty beat up. And anyone that you go into a factory and the people that are handling sheet metal, they're all wearing gloves for a reason. Is that it's sharp and everything else. And just imagine doing that 5 shifts a week as a person, and now you're having the bot do the same thing. So it seems like they should be able to do that because the payload is reasonably light, and the accuracy requirement isn't that bad when you drop it in. And the cycle time, all you have to do is meet cycle time. You don't have to be human speed. You just have to be able to hit the cycle time. So if you've got some of these lines that are running at a slower pace, it should be easy to keep up. Now, ideally, the high volume lines, you're trying to run your workers at about 85%. So if they're able to accomplish a task in 25%, you find a second task that they can do right nearby. They have to bounce between the two so that you kind of keep them at that 85% utilization. And as you can see with the BMW case, 84 seconds, that's like, man, that's a lot of time. That's plenty of time to go over, grab a part, drop it in there. And there probably was like maybe 3 parts or something like that in total that had to go in, or at least that's what the content was that they had to have. And there's different ways you can do that. You can do, if a person is able to do 2 stations, well, then maybe you have 2 bots doing 1 station a piece, but you want to make sure when you're at the end of the day, the hourly rate for that bot, when you look at all the costs in there, are on par with the human. And that, of course, the OEA or the success rate of the bot is also the same and not worse, because that's what really determines the ROI. If it's going to cost you more and there's more complexity, then there's almost no point moving ahead. But I think everyone realizes that this is still like an investment, that at first there may be some costs involved in the deployment, with the understanding that from this, we know what to do, that when the next generation comes out, it is going to cut the cost down and we'll be ready for it.
Wonderful. Thank you for that. That's great. I want to get this update from you regularly. Give us a State of the Union. It was fun to be able to go through a variety of different business models, different kind of bots, different way they're approaching it, who's a leader, who's not. And you've explained things very well. Thank you, Scott. People can follow you at Going Ballistic 5 on X. Actually, you're called Humanoid Botanist.
Botangelist, yeah, you'll see. But the handle is Going Ballistic 5. Yep, that never changes.
I kept saying to you, Scott, you should change your name to be Humanoid Scott. It's Humanoid Bot, Humanoid Scott.
Okay, we'll think about it. One's here too.
Thanks, buddy. Thank you, everybody. Bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.